Welcome to this instructional video by See Your Future. I'll be discussing this question. How can the volume of an object be determined by the water displacement method? The easiest way to understand this method is by discussing an example. Suppose that we have a container, such as a beaker or a graduated cylinder, that would have measurements for the volume of water that it contains. Now we will fill the container to a certain initial level of water. Now, the object whose volume we would like to measure is placed into the container. In this case, we will be placing a red ball into the water. When the ball enters the water, a change occurs, as represented by this arrow. The change is that the water level in the container rises. Keep in mind that each of the containers in this image are the same. The only difference is the introduction of the ball into the water and the rise of the water level. I will now draw lines to represent the initial and final volumes of the water in the container. Once again, the container must have markings on the side that show the volume of the water based on the level. The line on the container after the ball has sunk represents the final volume of the water. Once the measurements of the initial and final volume have been recorded, these two values can be used to find the volume of the ball. The equation that relates the volume of the ball to the initial volume of the water and the final volume of the water is as follows. The volume of the ball is equivalent to the final volume minus the initial volume. Now, let's try using this equation with values for the final and initial volume of the water. Suppose that the initial volume measured was 10 milliliters, and that the final volume was 15 milliliters. Using the equation above, the volume of the ball is simply 15 minus 10, or 5 milliliters. This was a simple example of the water displacement volume method, but it can also be used for many other situations. We could have placed several balls into the container, and the displacement of the water would have measured the total volume of all of the balls. In fact, this method will allow you to determine the total volume of any number of objects, provided that these objects fulfill a set of conditions. The first of these conditions is that the object or objects must be fully submerged in the water. This is to ensure that all objects are contributing to the volume level of the water. Secondly, the object must not absorb water. This is for reasons a bit beyond the scope of this video, but essentially, the volume of the absorbed water may not be the same as that outside of the object. For similar reasons, the objects must not undergo significant chemical reactions with the water. Signs of a chemical reaction occurring in the water may include a color change, bubbling, or the visible production of a gas. Lastly, you must be sure that the object does not dissolve in the water. Any of these processes listed above will cause a change in the volume of the water that is not due to the volume of the objects added. However, as long as you ensure that these four conditions are fulfilled, the water displacement volume method will allow you to measure the volume of any object that you would like. I hope you enjoyed this video and that you found it to be helpful. If you have any questions about what was shown in the video, please type them in the comment box below. If you have a question on another topic, please send us an email at questions@syfuture.org. Also, take a look at our YouTube channel for a full list of instructional videos. You can access this channel through our website, www.syfuture.org. Thanks for watching.